except for the coastal portion where you actually have the mist, and all the moisture. The rest of California is basically dry. I mean, it doesn't make a whole lot of sense to try to have a lawn to look good.
But it looks good, and it reduces stress, and it keeps the house cool. It wastes water.
It just wastes a lot of water. Um, the what uses a lot of water actually is not residential; it's commercial. So the farms, that uses a lot of water, and not only that, because they use chemical fertilizers and herbicides and all kinds of stuff, they also destroy the soil in the process. Yep. So we have multiple issues to basically deal with, unfortunately. All right. Well, I'm going to get started with today's lecture because there will be quite a few topics to talk about. The first one is the homework assignment. Okay, so I'm going to take a quick look at the homework assignment and see how many people have turned it in. That is under here. Okay, so let's take a look. It's not going to show the name, so it's going to be okay. 53 people turned in something. I'm not sure out of the 53 how many are actually working. Okay, because there's no indication, whether it is working or not. So what I'll do is I'm going to postpone the deadline, until tomorrow. Okay, so I'll give the entire class, this class and the next, another 24 hours. But people who turn it in early, will get, basically, all the full points, and then people who turn in late, will get I'm just making it a 20% deduction. Okay, which is not a whole lot. Okay, 20% is, I think is not too unfair. But you get if you spend the extra time, you can potentially get 80% of the entire homework assignment's worth. So I think it's worth the time. If it's not for the point values for the homework assignment, I think it is worth it just for the exercise of doing it and thinking through a program and try to debug a program in the process. Okay, so that's the arrangement. The due date is not going to change on paper here. Okay, it will still reflect this date here, but you can turn in late. Okay, I think the assignment is already set up so you can turn in late. So it will show up on my screen when I grade it that it's late by how many hours. Okay, so as long as it is late by 1 day or so, I will still grade it and have 80% of the points available. Yep.
If we already submitted it once, then we resubmit it.
You have to decide whether it is worth it or not. If you think what you turn in may not work in general, then it is worth it to kind of do it again and turn in the one that actually works, because then you can guarantee that I'm getting 80% of all the points. Okay. And can you guys see whether that thing is about to fall off, or is it just kind of...
I think it's just hanging. It's hanging on this side right here.
Okay, I can see it's hanging out of 2.5 corners out of the 4. So if you don't feel comfortable sitting under that thing, you can kind of move and make sure that you don't get knocked on by that thing when it falls. And I have no idea why it is like that. It wasn't like that on Monday. Maybe someone was using it as monkey bar. If it drops, the college has to pay for injury and property damage. I'm not going to pay anything. In fact, if it falls, I might walk over to there and go like, "Yep, I'm here. I want a few days off and medical compensation." And I'm protecting my students. I'm doing my job. All right, so let's go ahead and take a look at the homework assignment first. Okay, for those of you who kind of solved the problem already, excellent, not a problem. Okay, for those of you who are kind of still thinking about how to solve the problem, I can basically just kind of point out a few things. I'm just erasing the whiteboard. I would try to use mouse pad, as much as possible, so it will still be a part of the screen recording. And we just double check and make sure it is up and running. Yep. All right, so the approach to this problem is like this, okay? I'm not going to give you the exact code to do it, but I will give you a strategy to do it. So the strategy to do the homework assignment, which is sort for, is kind of like this, okay? Or one way to do it, I should say. Only one way to do it is like this. You can basically find which variable has the maximum, and this time out of w, x, y, and z. Okay, and we already talked about logic to do that already. Find max has this particular attribute. So once you find out which one out of the 4 variables has the actual maximum, then what you want to do is to exchange that variable with z. Okay, unless it turns out to be z itself, then there's no exchanging to be done. Okay, you can still do the exchange. Any logic to do swap or exchange will not work in this case, because if you use the exclusive OR, z exclusive OR with z is going to give you a 0, and there's no way to retrieve the original value back. Okay, so but the other way would work. Okay, the other way of exchanging will still work. If you want to use extra variables to get it done, so be it. Okay, you can use extra variables to do it. Okay, now once this is done, then z is already at the right place. Okay, so now you only have how many variables to worry about? 3 left. Okay, so the next strategy, and because I'm lazy, I do this. You just say copy and paste it, but this time z does not need to be considered anymore. Now we only have to worry about out of w, x, and y, which one is the maximum. Whatever maximum it is, you exchange it with y, and then you only have one more step to go. Instead of 2, you only got one more step to go, because at this point you only have 2 variables left between w and x, because y is already done. So between w and x, figure out which one is the maximum and exchange it with x. And once you have 3 out of 4 variables in the right place, the 4th one has to be in the right place already. So that's one strategy to do it. The other strategy is to use bubble sort, and then you just kind of blindly go through the bubble sort algorithm for 3 times, okay, which is guaranteed to find have the entire thing sorted. So that's the other way to do it. But this way, I think, is easier. Okay, from my perspective, this is easier. Yep.
But maybe I missed it, but we didn't go over bubble sort for arrays, so we couldn't use it as code.
Well, bubble sort is just an approach of doing things. You're constantly exchanging. You're comparing things to the one next to it, and if they're out of order, you exchange the values. That's bubble sort. And then you move on to the next one. If it is out of order, you exchange. And then you move on to the next one. If they're out of order, you exchange them. Okay. So you can use the general approach of bubble sort, even though this is not using an array. But I think this approach will work just fine, because we did talk about how to find the maximum, or find out which variable has the maximum, and there are a few ways to do it. Okay, we talked about that. So this approach, I think, will work just fine. The exchanging part, if you want to use a different variable for the exchange, that's okay. If you want to use the exclusive OR approach to do it, that works too. Okay. So is everybody feeling a little bit more confident, that you can get this done? Now that there's a kind of general strategy to do it? Okay. And remember, this is not the only way to do it. This is just one way to getting it done. Okay. Now with this out of the way, we can now talk about the exam. All right. I cannot pass it back to you yet because I have not graded it. What I usually do is I will scan this, and then I can pass the original back to you with no point values whatsoever written on it. It will all be reflected on Moodle as I do all the grading, using a PDF reader on one side and Moodle on the other side. So that's how I usually do the grading. All right, so let's go ahead and start to look into this. The first question is, well, it's an interesting one. So I'm going to repeat the question here, and then we'll go ahead and take a look at, how do we figure out, this one here. V1 is less than V3 if V2 is less than V3. And this is all without indentation, so that you have to figure out, how things are actually nested. So we have else k equal to 3, and then we have if v2 is less than v1, k equals 4. Okay, that's the code. There should be 10 lines, and there are exactly 10 lines. Okay, so this is the code, and the first thing I want to do is to say, well, I don't trust my own way of parsing this code. Okay, humans can make errors. So I'm going to plug this into a program and have the compiler to check it first. Okay. So here comes the compiler, my trusty assistant in this particular homework assignment or in this question. Now, obviously, you guys did not have access to a compiler. So maybe what I should do is I can explain it first, and then we'll use the compiler to verify that what I'm explaining is actually correct. Okay. Before I do any explanation, I'm going to go back to conditional statements here to kind of revisit what we talked about as far as conditional statements are concerned. So when we talked about conditional statements, we talked about, okay, when you read this part here, you can read the reference material of conditional statements here. How many people click the hyperlinks in the documentations? Okay, a few. Okay, so I'm going to open it up, but in case I need it, I have it available. In short, a conditional statement lets a program make a decision, choose one of the two possible branches to proceed. A conditional statement is also known as an if statement because most programming languages use the word if to start a conditional statement, and C++ is the same way. So I kind of talk about how I usually use it. Use an expression here. Use curly braces to surround the then block, and then use curly braces to surround the else block. Okay. But then I also explain, in this case, in a simple C++ code, what does that really mean. Okay. And then I look at this one, and this is when things start to get interesting. And there's an explanation of why this is not a part of the conditional statement. And this is the key to answering that question. Okay. So let's take a look at this one here. Why is this not doing what we think it's doing? Why n gets n plus 1 is not a part of the conditional statement? Because if we can explain this, we can explain the problem, or the lack of a problem actually, with the code in the question, in the test. Yep.
Is it because of the semicolon ending the expression statement? Because if is looking for a single expression statement.
Mm-hmm. And this is also not starting with else. Yep.
But wouldn't that just be itself just a separate statement?
N gets n plus 1 is a separate statement, sequential to the conditional statement.
So that's technically correct.
It is syntactically okay, but n gets n plus 1 does not happen only if x is less than 1. Okay, so now we have matching if and else's. So here is the question of where is this else corresponding to, and this is one question. This is also directly related to the question that is in the test, because this one also does not have an extra else for both ifs. Okay, it only has one else corresponding to the inner if, but the outer if does not have an else. So that's that's an explanation of that one. And then in class, I also kind of went through a few examples of how to parse it or how to look at it from the perspective of the compiler. So what we'll do is we'll go through that also and say, okay, let's see what the compiler is going to do. The compiler sees the word if, and that's a clear indicator that we are starting a conditional statement. Okay, there's no doubt, simple stuff. But whenever the compiler thinks, I have a conditional statement, it will anticipate certain things. So in this case, it will anticipate open parenthesis, the expression, close parenthesis, a single statement, and optionally else and an else statement. Okay, that's what the compiler is thinking. So it will find the open parenthesis, that's good. It will find the expression, which is the condition, that's good. Close parenthesis, that's good. Now it is expecting the then statement. Okay, what to do when the condition is true. It finds another if, which is okay. So that simply means the conditional That simply means the then branch of when v1 is less than v2 is another conditional statement. Okay, so in terms of, I'm just wondering whether I should draw a picture or not, and I think I'm going to draw a picture to represent this. So some of you may want to use a cell phone to take the picture afterwards. So at this point, what we have is to see the word if. We have a condition of v1 is less than v2, okay? And when we are expecting what is on the then side, when the condition is true, when we're expecting, okay, what should we do when the condition is true, we encounter another word if, right? So here's another if here. That indicates this entire branch is a single conditional statement, because I can only have one statement on each branch, and I'm not using any compound statements here. There are no curly braces whatsoever, so everything is just a single statement. So if with an if, I can now anticipate the condition, which in this case is v1 is less than v3. Okay. When I'm done parsing the expression, I'm now expecting a then statement corresponding to v1 is less than v3. So now I say, okay, this part is mandatory. What is the statement for me to execute when v1 is less than v3? What do I see? I saw another if. I saw the third if on the third line over here. So I'm just going to reflect that here so that we can see the highlight correctly. So as soon as I see the compiler sees an if, it says I need a condition. Okay, tell me what condition I'm looking for. In this case, it's v2 being less than v3. That's the condition. But once the condition is parsed, it is now again expecting a then statement. Okay, what do I do when this condition is true? Over here. And that's the next line, k equals 1. K as a single symbol does not match any keyword. It is not if, it is not for, it is not do, it is not while. And we haven't really talked about return and switch and other statements, but it doesn't match any one of those keywords. So automatically the compiler says, okay, we have an expression statement here, okay, because it doesn't match any control structure statement. So now it says, okay, we'll parse k equals 1. And k equals 1 by itself is an expression, okay? But it is expecting a statement. Fortunately, we have a semicolon, because a semicolon is a terminator to turn an expression into a statement. So at this point, the statement is done, okay? The then statement is done. When the then statement is done, the compiler says, okay, I'm still in the middle, potentially, of parsing a conditional statement, because any conditional statement can potentially have and else associated with it. Okay, what to do when the condition is not true, right? So what does the compiler see next?
Else.
Exactly, else. Okay, because at this point the compiler sees, oh, okay, I see that there's an else here. So when the compiler sees the word else, it automatically says, oh, okay, now I can anticipate an else branch. Okay, a statement to execute when the condition is false. Okay, so the else is going to be here, and it's expecting a single statement at this point. When it's expecting a single statement, what it sees initially is the word k, or the identifier k, and once again, k does not match the beginning of any known control structure. It is not for, it's not do, it is not while, it is not if, so it must be an expression statement. So now, what the compiler does is to say, oh, okay, we have another expression statement. Let's parse the expression. The expression is k equals 2, and that's only an expression. I want a statement. The compiler said, I want a statement. Fine. I'm also seeing a semicolon that turns it into an expression statement. Okay, do you guys have any questions back there? Can I answer your question? No? Okay. All right. If you do have a question, let me know, and I can try my best to answer the question. Okay, so at this point, the compiler says, I'm done with this conditional statement. I found the condition, I found the then branch, I found the else keyword, I found the else branch. I'm done with this conditional statement. So the parsing now moves all the way back to this conditional statement. Does that make any sense? Okay, and not this one, because we cannot skip. It's just like matching parentheses. You have to close parentheses of the innermost open parentheses first before you move to the outer ones. So at this point, the compiler is going back to this point and say, okay, I'm done with the then branch of this conditional statement, I can now extract an optional else keyword. Is that okay so far? Because the else keyword is optional. But the compiler says, oh, but I do find the else keyword here. Okay, there is an else corresponding to v1 is less than v3. So finding that else keyword, it is now expecting a single statement corresponding to this branch here. And what does it see? It sees k equals to 3. So once again, k is not any keyword to start a control structure. So now the compiler says, okay, I know we are just expecting a expression statement, which is in this case k equals to 3. And since there's a semicolon after that, it becomes an expression statement instead of just an expression. And now the compiler says, okay, I'm done with the conditional statement of v1 is less than v3. It is time to move back up one more level. So now I'm back to the parsing of v1 is less than v2, and I'm looking for the optional keyword else, okay, to basically signify, hey, this expression has an else branch. And what does it find? It didn't find else. Instead, it finds if. So without the else, which is optional, this whole thing is now done because I cannot find the else that is optional, which means it doesn't have to be there. Since else is not here, I don't have an else branch to specify with this expression. So the next if is going to start the next expression or the next statement. So the next statement is a conditional statement that is sequential to the first one. Effectively speaking, we have two conditional statements from the outermost layer. The first one is this one here, and then the second one has the condition of v2 is less than v1, and it only has a then branch too. Yep.
Why can you not use that line 9 as, which is the v2 less than v1? Why can't you use that as the else condition?
Because it doesn't have the word else. When the compiler gets to this point here, it has an option. It's basically saying, if I find the word else here, then v1 less than v2 has an else branch. If I do not find an else keyword here, that means this conditional statement has no else branch. I'm starting a new statement altogether. So that means in terms of indentation, if I use indentation to indicate the level of the statements, it will look something like this. This else belongs to the innermost conditional statement. This else corresponds to the middle layer conditional statement. Oops, there we go. And then this statement is completely independent from the first. So we have one conditional statement here, and then we have another one that is sequential to the first one. Yep.
In the questions, it asks you, like, when you get to the bottom separate if,
Right.
like, it asks you for v1, v2, and v3, and I wrote v3 could be any value because it doesn't matter.
That is correct. That would be.
So that would be good.
That would be good because but you still have to trace through the entire code to get to it, because if you look at the third part, the last part of the second branch of the conditional state of the question, it says pick any three values from x1 to x7 to initialize v1, v2, and v3 prior to line 1 so that execution reaches line 10. That's the question, right? So this is line 10 right here. I just need you to give me values of v1, v2, and v3 to get to that point. So you have to pick something to get to that point. Because if you don't specify v3, then the execution through this part here cannot be traced.
Isn't it only applying it to v1 and v2? So
Just pick something. I mean, v3 does not affect that part at all. It does not affect whether you reach v10 or not. I mean, line 10 or not. But the question does say specifically, pick any three values from x1 to x7 to initialize v1, v2, and v3. So each one has to be initialized. If it's not specified, then you're only answering a part of the question. You're not answering the entire question.
if it's not specified, it could be any number. And so that's still work. If it's not
But then you're not picking a value from x1 to x7 because x1 to x7, none of those 7 numbers is uninitialized. They're all actual values.
It's because I wrote it could be any number, but I didn't want to put anything. And I was frustrated with the last problem, so I didn't even have time to ask that question.
Well, I can only grade based on what the question is asking. So the criteria is you have to pick 3 values from x1 to x7. Unspecified is not one of those choices. So you're not going to get full credit. You'll get partial credit for that because in the end you did figure out how to get here, but then you won't be able to show me how you get through this part. You can show me that you can get to this part, but you won't be able to show me how you get through this part. Okay. Yep.
Something similar to this would work for the homework too.
Something like this.
Code.
I recommend you guys use your curly braces to clearly indicate the nesting level because this is a good example of showing you guys what not to do, right? Because if someone actually does this with actual commercial program, the person who's going to read it to have to fix bugs or to understand what it does is going to have a major problem with this. Okay, now the lack of indentation is actually a good thing because if I give you the wrong indentation, it can be worse. Okay, think about it this way. What if someone gives you the wrong indentation like that? Well, unless you can parse like a compiler and completely ignore the indication based on indentation, this is the wrong interpretation of the code. Okay, the conditional statement is not a part of the else branch. Okay, this conditional statement is an entirely different statement. It is not a part of the else branch. So that's why this is the exact reason why I say, well, when you are writing your code, use curly braces so that the nesting is clearly indicated. But as a test, I'm testing whether you guys understand, what is a conditional statement in C and C++. Yep. Oh, okay. Got it. Yep.
So even though there's no else for the first intent, is it wrong? It can still work though, right?
Syntactically, it is correct. And that's what the question is asking. The question is asking, is there a syntax error? That's the first part. If so, answer the following questions. So the question is not asking, is the code doing what it is supposed to do? Because I didn't tell you what it was supposed to do, so you cannot possibly answer that question. So the question is just asking, is there a syntax problem? Is the syntax wrong? And if not, then you move on to the second part. If it is wrong, then you answer the first part. Yep.
I didn't want to leave that blank, so I just put a dash or something. Was that okay?
Yeah, if you say not applicable, a
Yeah.
dash, and say everything is good, it's okay, But if you write down and say the syntax is actually wrong, then I have to kind of grade it, accordingly.
All right.
Yep. I have to figure out how to assign partial credit in this case because I think people, some people did not answer it correctly, but yeah, we'll see. All right. Any questions about the conditional statement? I mean, at least after the fact, does everybody understand how to parse a statement like this? Okay, kind of? Okay. But you cannot trust me, can you? So since you cannot trust me, this is what we'll do. So what we'll do is we are going to copy this into an actual program and at least be able to compile it. Because the question is it a syntax error? So let's go ahead and check it out. So we'll create a program. Let's just call it q1.cpp for question 1, and I can do a paste. Control D to stop here, and then I'll give a q1 the appropriate beginning and the end. I need to give it integers for v1, v2, v3, and k. Just to make the compiler happy, it needs a return. And that's the entire program. The compiler is not going to be happy because none of these are initialized. So what we'll do is we will use GDB to test it. So G++ dash G dash O Q1 plus CP. Expected identifier. Oh, forgot about the semicolon. The error message did not say a single thing about semicolon, did it? Let's do it again. That's the error message. The error message says expected initializer before if, and it's complaining on line 5 as if the problem is with line 5, but the actual problem is on line 3. I forgot to put a semicolon here. So some of you will remember this, so the next time you see a similar problem, you know it may not be the line that is reporting that has a problem, it can be the line before that is causing the issue, like just missing a semicolon. But is it really just missing a semicolon? Yeah. Yes, it is. Now how do we test a program like that? There's no initialization whatsoever, there's no cin, there's no scanf or anything to input numbers. But there is GDB. So when you write a program like this, okay, when you want to write a very simple program to test a certain concept that we talk about in class, you don't need to initialize everything. So what we do is we put a breakpoint on line 5, which is the first line that actually does anything useful, and then we run the program right away. Now obviously at this point, V1, V3, and V3 are all uninitialized. This is where you can do some initialization in the debugger to test your program. So we can now say set V1 equals to 3, set V2 equals to 5, set V3 equals to 7, or pick whatever the combination you want to pick. Yep.
Can you not initialize 3?
Sorry?
Well, it's too late now.
Can I what?
Not initialize 3.
Not initialize V3?
Yes.
Then it remains uninitialized, which means it has a value, but we don't know what the value is.
Yeah.
Well, we can always start from the beginning, right? The breakpoint on line 5, run the program. Set V1 equals to, what was it?
3.
Doesn't matter. Okay, so we want to see what is in V3, and it's some really random number.
Yeah.
Yep.
That's what I was talking about.
Yeah, but that's not what the question is asking. The question did not say, leave it unspecified if you think that value does not matter. You're supposed to pick from V1, X1 to X7 for each of the variables. Okay, so for this particular purpose, we're going to set it 7, and then you can single step at this point. You can single step, it goes to line 6, because in this case, V1 is less than V2. V1 is less than V3, so it will go to line 7. And then since V2 is also less than V3, it will go to line 8. After line 8, it will get out of the entire conditional statement and proceed onto line 9. On line 9, V2 is less than V1 is false, so it will skip line 10. I mean, what is line 10 in the original question, and get to the return statement, and we're all done. So this is how you can test it, but the whole point of compiling is just to make sure that the interpretation of the logic is in fact correct. All right. So are there any questions about number 1? Yep, go ahead.
So if the conditional statement, the V2 is less than V1, I will only go to the line 1 and line 2, right?
You would, okay, if V2 is less than V1, then you go to line 1, you skip all the way to line 9, and then you go to line 10.
Okay.
So your execution path will be line 1, line 9, and then line 10. Yeah.
And all of them, I don't need to copy.
Right, there's nothing to go in. Yeah. I see your point, of V3 not really, taking any role in the whole thing.
I'll talk to you afterwards.
Okay. So since V3 is not really taking any role,
Well, it says
V1 is
any
less than
variable, so I said any number.
no, it did not say any number. It says pick any 3 values from X1 to X7. That was very explicit in the question.
This is like
like a
You're
lawyer.
in court, you know?
Yep. Well, if you think I'm picky, wait until you have to deal with the compiler.
Yeah.
And you cannot argue with the compiler. You can scream at the compiler all day long and nothing happens. It's like, you're still wrong. Not compiling. All right, moving on to question number 2. Question number 2 is also interesting on its own. And this is the one that I cannot really illustrate using a debugger. Okay, so let's move on to question number 2. It is x1 minus equal to, in parentheses, x2 equals to minus x2 minus equal to x1 plus equal to x2, close parentheses. All right, so this is the expression that is given to you, and you need to tell me the value of each sub-expression as well as the side effect of each sub-expression, like which variable is it changing, and if it is changing that variable, what is the new value of the variable. So that's, those are the columns that you have to fill in for this particular question. Okay. So I'm going to start with a condition. So let's just say that x1 has a value of 5 and x2 has a value of 8 to begin with. Okay, I'm just randomly picking 2 numbers. Okay, so in this case we want to start with the innermost portion first. Okay, which is always the case when you evaluate any expression. Okay, you always go to the deepest portion, evaluate that part first. Okay, can someone tell me what is the result of x1 plus equal to x2? The value of the expression is going to be what? 13. Because 5 plus 8 is 13. Is there a side effect to this particular sub-expression? x1 becomes 13. Okay, so x1 becomes 13. Okay, so not using the column format, this is the way I represent it. Okay. All right, so when this is done, the next level up is to evaluate only this portion without the negation on the outside. Okay, what do you think is going to be the result of x2 minus equal to x1 blah 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 blah? We already know this part is just giving us a value of 13. So what is x2 minus equal to 13? Negative 5. Very good. So negative 5 is both the expression value and also the side effect. Okay, it is both. So with the second level expression, we have the value of the expression is negative 5 because 8 minus 13 is negative 5, but we are also storing that result back into x2, so the side effect is x2 now becomes negative 5. Are we still doing okay so far? Yep.
In my case, I had x1 was 5 and x2 was 5.
That's okay. If x1 is 5, x2 is 5, then you will have you should have negative 5 because 5 minus 10 is negative 5.
Yeah, okay. I think I did. But I was just wondering because it's more confusing when it's two the same numbers than I mean, I'm sorry.
Okay.
I think keep going, but I was wondering about that.
Okay. All right. And then the next level up is this part here. Okay. So we already know that this part here, this is negative 5. So what is x2 equal to negative 5, the negation of negative 5? It becomes 5. Okay, very good. So the next level up is the value of the expression is 5, but at the same time we are also updating x2 to 5. So, yep.
That's a different way of switching the numbers, huh?
Yes, it is.
Yeah, that's what I figured out too.
So now we have the overall expression. So the overall expression, the entire thing, is x1 minus equal to 5. Now you have to remember x1 is no longer 5. We changed x1 in the first step. So x1 is now 13. 13 minus equal to 5 is what? 8. Yep, the entire expression is returning 8, and x1 is also updated to a value of 8. So in the end, we just exchanged the values of the two variables, which is a very long and awkward way to do it, but it works. Without a third variable either, yes. Well, the exclusive OR method works too without a third variable. This one works as well. So are there any questions about the answer to this question? Questions about this one? Let's move on to the third one. The third one looks a little bit more difficult than the practice test, because this time I asked for any updates to xi or x8, but by doing so, I'm actually making it easier. Because if I don't ask for it, some people will try to track the changes of the variables in their mind, and that can get messy real quick. By writing it down, it's actually easier. Okay. So what I'll do is I'm going to write the program first. This is line 1 for I equals to x1, x is I plus plus. Okay, so that's the first tricky part is the post increment here. I is less than x8 minus x8 is the first line. The second line is just an open curly brace. The third line is x plus or equal to plus plus I. Line 4 is the closed curly brace. So the question is asking you to fill in the rows where we have to indicate which variable is getting updated on which line, the line number, and also what is the new value of that variable. Those are the 3 columns that we have to fill in, starting from the very beginning of the entire control structure. So from the early part of the control structure, let's also give x1 and x8 some particular value. So in this case, I'm going to assume x1 has a value of, I'm just going to randomly pick 3, and I'll also randomly pick x8 to be, I don't know, let's pick 7. Okay, 7 works. The only question is how many times do we want to go through this? I mean, that's the only question. Okay, so on the first line, this portion is referred to as the initialization of a for loop, which means it has to be done before the loop. It doesn't get repeated. Okay, this is a one-shot thing that has to be done before the loop happens. So that is what is being done first. The question specifically asks that you enter, if you have multiple variables updated on the same line, you have to separate those as different rows in the trace. So in this case, I have to separate the update of I on one line. Is on line 1, I gets updated to the value of x8 first, x1, sorry, it is 3. And then we update x, the value of x, also on line 1 to I plus plus. Now, when that happens, there are 2 things to happen. The first one, now this one can be interchanged. You can say you update I first. You can also say you update x first. But you have to keep track of which value are we using to update x. So I personally would do it this way. I would say the current value of I is used to update x, so x has a value of 3, and then after that we have a post increment operation so that I becomes 4. Okay? But the order can be exchanged, okay? Because the compiler can choose to update I first and then update x. As long as x ends up with a value of 3, it is still okay. Are we doing okay? Yep.
I think you had right after the 4 in the first curly brace, you had more than one. Maybe it just looked a little bit different.
Did you take the test for the morning class or did you take the afternoon test?
Morning.
You took the morning test? This is exactly the code that I'm copying from.
So you would have put in X1 or X8.
This one is just x. Yep.
Isn't post increment the one where the value doesn't change?
Say again?
Isn't post increment the one where it adds 1 and then takes 1 off?
It takes 1 off when you look at the entire expression. It's not really taking it off. It's adding 1 first, and then you refer to the updated value and then minus 1, subtract 1 from the updated value. So you get the original value back.
Okay, so that doesn't go where x is?
It basically says x gets the original value of I first, and then the increment affects I afterwards. That's why it's called a post increment, because it returns the value of I first, and then it increments I after the fact. So that's why it's called post increment. Okay, so the next thing we do is to evaluate the expression I is less than x8. I has a value of 4 at this point, x8 has a value of 7, 4 is less than 7 is true. That part you do not have to reflect in your trace. The next update happens on line 3, and there are 2 of them, okay? And once again, you can use, the order is not important in this case because the compiler actually can choose which way to do it. So you can basically say x is updated first, okay? So when x is updated first, then, in this case, no, I take it back, sorry. I has to be updated first because I is a pre-increment, so the increment happens first. On line 3, I gets incremented from 4 to 5, and then on the same line, x is incremented, or we add 5 to x to become the new value of x. So x is now updated, on line 3, x is now updated to a value of 8. And then we are not done yet, okay? We cannot just kind of go back here and say, oh, we evaluate the condition and see whether it's time to get out, because there's a post operation here. So in the post operation, which is on line 1, we update x8 in this case on line 1, and it is decremented. x8 started off with a value of 7, and now it has a value of 6. And then we go back to reevaluate the condition of the loop. It is no longer true because it is still true. I has a value of 5 at this point. x8 has a value of 6 at this point. It is still true, so we have to go back in to line 3 and then perform the other operation on line 3. So on line 3, once again, we update I first. I is incremented from 5 to 6 first, and then x is now incremented by the value of I. So x goes from 3 plus 6, which is 9. Oops. Sorry?
Value of x, which is 8.
Oh, okay, right. Okay, it's 8 plus 6, which is 14. And then after this, we go back to the post operation. We decrement x8 by 1. So x8 on line 1 is now decremented from 6 to 5. And then we go back to reevaluate the condition. I at this point has a value of 6. x8 has a value of 5. 6 is less than 5 is false, and we exit the loop. And this is the trace. This is the full trace. Are there any questions about this particular one?
Explain the post.
The post decrement? You mean the minus x8?
Yeah.
That one is a post decrement, which means in this case, whether it's pre or post doesn't really matter, because no one refers to the expression's own value. The expression is evaluated, but nobody cares about the value. So the only thing that you have to know is what is the side effect of this expression. Plus plus is pre-increment, minus minus is pre-decrement. So it subtracts 1 from x8 in this case. Any questions about this one? Questions? Okay. Moving on to the last one. Okay, the last question is open-ended. Okay, it says use only control structures, assignment, addition, and comparison. Write code to do the following, and it states here, given an integer n that is at least 1, compute the least power of 2 that is greater than or equal to n, and store that value in variable p. This means p should end up with a value of like 1, 2, 4, 8, 16, and so on when the code completes. In other words, I'm trying to differentiate the actual power of 2 as opposed to the exponent of 2 to get to that number. Okay, so 1 to the power of 0 is, 2 to the power of 0 is 1. So 1 is a power of 2, but 0 is the exponent to get 2 to the power of 0 to 1. So I was trying to make sure that we differentiate the exponent from the actual value that is a power of 2. Okay, so you can do it a few times, just do it by hand first. And a few people actually came to me and asked me, okay, is this the right interpretation of the question? Which is okay. I mean, that's actually okay. So if n starts off with a value of, let's say, 71, okay, when this computation is done, what should be p? In other words, what is the smallest power of 2 that is greater than or equal to 71? 128. Yep. Let's use another example. One more. Okay, let's try 4. Okay. So if n is 4, what is the smallest power of 2 that is greater than or equal to 4? 4. Yep. Okay. So are there any questions about what your algorithm is supposed to do? Yep.
Why is it 4?
Huh?
Why is it 4? Why is it
Because 4 is a power of 2, and then 2, 4 is greater than or equal to 4.
But why is 128 so much bigger than 71?
Because 128 is the first power of 2 that is greater than or equal to 71.
It's not a power number.
It is.
128 is a power of 2. 128 is 2 to the power of 7. So 128 is 2 times 2 times 2 times 2 times 2 times 2 times 2. That's why it is a power of 2. Is that okay? Not to the power. It's a power of 2, not to the power of 2. Power of as opposed to power 2. 6 to the power of 2 is what? 36. 2 to the power of 6 is 64. Yep. And which one is a power of 2? 64 is a power of 2. All right? Okay, so your code will have to keep track of p, okay? So let's see how we can do this, okay? Let's look at what is permissible and what is not. You are allowed to use comparison operators, okay? Comparison would include less than, greater than, less than or equal to, greater than or equal to, and not equal to, okay? So those are allowable. You are also allowed to use addition, assignment, and any of the control structure that we have talked about. We talked about if, we talked about for, we talked about do while, we talked about while, and I think that's it. Those are all the control structures that we talked about. Okay, so these are the components. Sorry? Negative? It doesn't say negative.
Oh, sorry.
Yeah, it says, let's see. Okay, in the first paragraph of the question, use only control structures, assignment, addition, and comparison. So negation or subtraction is not a part of it. And you don't really need it either. Okay, you don't really need it. Okay, so these are the things that we need. And since we have to compute the power of 2, so how do you do powers of 2 using only these operators? Let's rule out certain things. To compute something, okay, these are comparisons. They cannot give you an answer of a computation. So it cannot be these guys. These are control structures. They cannot update anything by themselves. Okay, they can control whether to do something over and over again, or whether to do something or the other branch, but they cannot update anything by themselves or do any computation. So the only thing you really can do to do any type of computation is addition. So the question now is, with only addition, how can I compute a power of 2? Okay. Well, it's adding something to itself, is multiplication by 2. Okay, that's basically what it is. Okay, so now to pick a control structure, should we use an if statement here? An if statement is not going to work. It's not going to work in this case because it's a one-shot kind of thing. Okay, there's one condition, you evaluate the condition, and then you say, oh, okay, we need to go for this branch or this branch, but you can only do it once. Okay. And in this case, you can't really get to P in one single shot. Okay, What about a loop here? Okay, so these three are corresponding to loops. Loops may work. Okay, so what we want to do is to say, well, let's try to use a loop here. Now, if you do it by hand, how would you do it by hand? If I give you a number like that, okay, I just randomly click something on the keyboard. Okay, if I give you a number like this, how can you figure out the lowest power of 2 that is greater than or equal to this number? And you have to do it in a systematic way. Okay, some people know the math and say, well, I can use log, right? The log of this number divided by the log of 2, and take the ceiling of that number, and then take the 2 to the power of that number. That will fix the problem. Okay, closed form, which is nice, right? So P equals to 2. Okay, in C there's no caret. Okay, remember what the caret means in C and C++. What does it mean? Exclusive OR. Okay, so this symbol is not to the power of in C and C++. It doesn't work. Besides, it's not one of the things that are allowed to do anyway. So what you need to do is to say, okay, we are taking the 2 to the power of something. And that turns out to be the ceiling function. I'm not going to talk about the ceiling function. I'm just giving you the closed form of this stuff here. So we're taking the ceiling function of the log, whatever base you want to use, doesn't matter. Okay, you take the log of n, you divide it by the log of 2, and then you take the ceiling, and then you take the power of that thing. That will give you a closed form of the answer. But since you cannot use any one of these things, because we're involving log, division, and power, none of these is allowed, so you can't use this function. So without using these things, how do you do it systematically? You start with 1. Is 1 a power of 2? Is it greater than or equal to the number that we're dealing with here? 92,031. Nope. What is the next power of 2? 1 plus 1 is 2, and 2 is that a power of 2?
Yes.
Yep, it's 2 to the power of 1, but doesn't meet our other criteria. The next one is 4. 4 plus 4 is 8. 8 plus 8 is 16. Yep.
How can you make a condition and ask if it's the power of 2 when you can't divide?
Because all of these numbers, by their very nature of how they're computed, they must be powers of 2.
So how would you make your loop show 2, 1?
Well, that's where we're getting at. Yep. So we have 32, we have 64, we have 128. It seems like it will take a long time to get to the answer, but because of the exponential nature of this thing, it's not going to take that much of a long time. 256. Next one up is 512, 1024, 2048, 4096, 8192, 16364, 384. And then we have 32,768. And then we have the 65566. Oh, 6.
Yes. Yeah.
65566.
Yeah.
Okay. And then the next one up will do it, right? Which is, I'll cheat a little bit here. Whatever that is. Or we can use a spreadsheet. Or I can write it in binary, that would be easy to do, or in hexadecimal, that would also be a very easy number to write. Okay, so that number is going to meet the criteria. So what do we do in each step? We double the number from the previous one, okay? And adding a number to itself is going to double it. And then we have to compare and say, is 128 greater than or equal to this number? No, move on to the next one. Is 256 greater than or equal to this number? No, 512. So we keep testing it. So this gives you a structure of, okay, maybe a loop will do it, okay? So we'll say, now because the answer is P has to be greater than or equal to N, that means as long as P is less than N, we are not ready to get out yet. Is that okay? Now, when you're inside this loop here, what can you possibly do? Well, there are a lot of things we can do. Okay, we have assignment statements, we have addition, and we have two variables. Okay, so there are like a few combinations of what you can do. But since we know we're doubling something, okay, so we know that on one side we are going to say we have an addition. I mean, this is the only right order to have assignment on this side and the addition on the other side. So the only question now is, what do we put here, what do we put here, and what do we put here? Okay, let's answer this question first. Can I put "and" here? Am I supposed? Can I change the nature of the question? If someone asks me, what is the least power of 2 that is greater than or equal to 13, okay? Can I say, I know 1 is greater than or equal to 1 and use it as an answer? Nope, because I'm not supposed to change the question itself. So this side cannot be "and". If it cannot be "and", it can only be "p". Now, how do we double the value of something? Adding something to itself. Okay, so we are almost done. If you give me this answer, you will have one little minor point deducted because of the lack of initialization. Because only one of these two is initialized. Let me see if I emphasize that is not initialized. I didn't say that. Okay, "n" is already initialized, but "p" is not. So the only thing you need to do is to say "p" equals to 1 to begin with. That's it. That's the entire program. Well, one way to solve the problem. Okay, I'm not saying that there won't be any other ways to solve the problem, but this is one way to do it. Any questions about this one? Yep.
We get marked off and we leave the semicolon after.
Probably not a whole lot. It depends on how the class is doing as a whole. If everybody came up with this and you're the only one who missed a semicolon, then I might ding you for missing that semicolon. I don't think that's the case. Okay, I really do not think that's the case. So with this one, if you get the main part of the logic right, you're gonna get the credit for it. Yep. Can P be 3? No, because if you use a 3 to begin with, then 3 itself is not a power of 2. So no matter how many times you double it, it's still not going to be a power of 2. Can you repeat that, please?
I'll count to you.
Okay. Go ahead. Can we retake the test? Well, there is a second exam and a final exam, so there's hope. Yeah, go ahead.
It looks much easier than how you worded it.
Say again?
It looks much easier than how you worded it.
Okay, I'll take it as a subjective comment. Any other questions? Yep.
Compound assignment operators really not be allowed?
It is allowed.
Plus the-
It is allowed. So if you want to do something like this, that'll be fine too. But you won't get any extra credit for it. Because sorry.
I just wanted to make sure it was kicked and done.
No, it is okay because I specified addition and assignment. This is basically a combination of those two, and I did not specifically say which one is permissible, the single one or the compound one. So this is okay. It does not conflict with what I'm asking for. Okay, any other questions about this one? No questions? So we are all done with the review of the questions. Oh, okay. This is the part where I need to mention the grading scheme. How many people still remember how I assigned your letter grades? A, B, C, D, F. Okay, so what do you need to get a C out of this class so you can get into CISP 400? 37.5%.
You say what? 37?
37.5% is a C. Okay, so if the objective is to pass this class so you can move on to CISP 400 or fulfills the requirement of some engineering or math or physics or chemistry degree, 37.5% is the minimum that you need to get out of this class. Yep.
So if you get one of these problems right, okay, one and somewhat of the other one, then you get the C.
Then you get a C for this particular exam, yes.
Yeah.
I have to be very specific because I don't want people to come back to me and say, but you said, but I can just get one and have a good question right this time and I pass this entire class. No, you pass this test with C, yes. See, I have a lawyer kind of daughter, so I know all of these arguments. Okay, any other questions? So that means, what does that mean? Okay, so let's go back to the grade assignment thing. Let's say I flunked this test completely. Okay, I did not answer a single thing. I write down my name, my student ID, and I just walked out of the classroom. Okay.
Is that an option?
There's always that choice. Yes. So I lost 20%, right? So the highest possible percentage I can get out of this entire class is going to be 80%. So let's just say that I'm not exactly a student that can get everything done right. I mean, I make mistakes in my classes. So I know I'm not going to get 100% of everything. But I can probably get, I don't know, maybe 80% or so of everything that I do, homework assignments, the second exam, and the final exam. Okay? So what is 80% of 80%?
100%.
Okay, I'll give you 4 choices here. Okay, the 80% of 80%, okay, is a 800%, 880%, 160%, 16%, or I said, okay, 5 choices, or 64%. 64%. And if I get 64% of all the possible points out of this class, what grade am I getting? A B. Yep, because the threshold for a B is 62.5%. Remember the one thing that I talked about in the first class? Someone can flunk everything, ace the final exam, and still walk out of this class with a C. Remember? Because the final exam is 40% of your final grade. And you only need 37.5 to pass the class with a C. I also said do not try it, okay? Do not take this as a challenge and go, I will prove you wrong, Tech. I'll be the first one who can do this. That would not be a good thing to do. Not wise. It can be done, not wise. Okay, so I want to mention this just so that you guys don't feel really like, this is really bad. It's not the end of the world. I mean, for people who are feeling really, really down because I really didn't do very well in this test, that's not really too bad. Any other questions about this exam? Yep.
Besides this exam, are you going to give us any extra credit on the homework or during the exam?
I might give you an extra homework assignment at the end of the semester. Okay, it's usually something that is, as the name extra credit implies, it is going to take some extra effort to do it. So it will be a combination of concepts that we have learned, but usually it involves a combination that is, not a straightforward way. Yep. Any other questions about the exam? No? Okay. Yeah, it's going to take me a while to get it graded. Okay, but at least you have the answers to all the questions. So for reference purposes, you have at least that much. The reason why it takes me a long time to grade it is because there's the procedural part, just the physical part of destapling every single one, going through the scanner, and then restaple one. That takes a little bit of time. And then there's also the evaluation part where I have to kind of scan through, like maybe 1/4 of all the exam questions, just to figure out how people can get it wrong and not completely wrong, so I can come up with a grading scheme that can assign partial credit accordingly. Because I don't think this class wants me to do it in a all or none way. It's like correct or not, right? I mean, that would kind of be brutal. Okay, so I don't want to make my grading like that. When you go to work, it's kind of like the opposite. Okay, your boss doesn't really care how much time you spend on the project, or it is done 98%. If it's not working, it is not working. Okay, but since this is not a work situation, I would count partial credit and go, well, this person understands this much of the concept. So it's basically based on how much understanding of the concept are you demonstrating to me, and that is how I would assign the partial credit. All right. Any other questions that you want to ask? No questions? And no, I'm not getting evaluated this semester. There was one semester I was actually evaluated in that semester, and then the dean chose the one day that the students are getting back the grades to do my evaluation. And I go like, fine, you'll pick that day. Yep. All right, so we'll talk about this on Monday. So on Monday, we'll continue the discussion of files. Okay, that's where we were at last time. All right.
There's still hope.
Well, there's always hope. After the final, then there's not much left. Yeah, but up until the final exam, yeah, there's always hope.